here's the skill. To get through chapter 12, you simply know how to do this. Can you take a weight? So give me the units of weight. What is a weight unit? Grams, milligrams. So I'm going to stick in milli. Everything's milli. So can you convert the weight of something in milligrams to the number of molecules? What are the units in molecules? Millimoles. Moles, M-O-L-E-S, moles. Moles is the count of the molecules. So can you take the weight of something to determine the amount of molecules? And then can you go, today we are going to convert the number of molecules to the amount of electricity generated by those molecules. Because do all elements have the same valence? Valence is charge, charge is electricity. So we're going to be calculating Milliequivalents, which is really factoring into the charge of those ions when they dissociate. Next class, we will be then counting particles when we'll be doing milliosmoles. So instead of charge, we'll do milliosmoles, or number of particles. But really, milligrams to millimoles to milliequivalents, or a milliosmole. So those are all we're doing in chapter 12. As soon as you get that down, it's a piece of cake. So let's work on some of these questions together here. And in this question, it's really repeated for both the high and low end of the range here. But it starts with the sodium. And the first question it wants to know about sodium is we want to convert 2 milligrams per deciliter. We're trying to get 2 milligrams per deciliter. What are we starting with? Well, for sodium, we are starting in milliequivalents. So we want to go from milliequivalents per liter to milligrams per deciliter. All right? Can you do that? All right? So again, I'm going to show you the low end of the range. The low end is here and the high end is here. The math is the same. So this was just a chance for you to practice both of them. So just let's focus on one of these. If we start with 135, the low end of the range, we said that those units are milliequivalents per liter. So we have 135 milliequivalents per 1 liter. So to get to weight, to get to milligrams, we have to get to millimoles. So what is the relationship between a milliequivalent and a millimole? Can you do that? For any specific ion, how will you know what numbers? It's going to be the valence. The charge on the valence goes with the milliequivalents. Remember, milliequivalent means equivalent amount of charge. How much electricity? So for every 1 sodium molecule, how many charges do you get? 1. There's 1 charge on a sodium. But is that the same for calcium? For 1 calcium, how many charges do you get? 2, because the valence is 2. So this is where you've got to know a little bit of your chemistry there a little bit, all right? So in this case, and we'll get to calcium here in a minute, but for sodium, since the valence is a positive 1 milliequivalent, the charge goes with the milliequivalent for every 1 millimole. 1 molecule of sodium gives you 1 set of electricity. So at that point, when we multiply that, we convert, we're in millimoles. So how do you convert from the number of molecules of sodium to the weight? We use the formula weight. The formula weight in milligrams is equal to the millimoles. 1 millimole for the formula weight in milligrams. You may have learned this in chemistry in grams per mole, and we're saying the same thing. We never do grams per mole in pharmacy. Those are too high a number, so we're usually always in the milli version of that. It's the same thing. For every formula weight in milligrams is equal to 1 millimole. All right? Since we were in millimoles of sodium, if I multiply by its formula weight of 23 milligrams, then, and again, that's equivalent to 1 millimole of sodium, we are now in what we desire, our units of milligrams. We've converted from milliequivalents to millimoles to milligrams. It's all we did here. All right, but we're not quite done because we want it in per deciliter, and we were given it into it per liter. So we got to convert our units, our volume units at the end. And remember, deciliters are smaller than a liter by 1/10. So there are 10 deciliters for every 1 liter. So if I multiply by 1 liter over 10 deciliters, 1 liter cancels, and I'll end up with deciliters in the denominator there. So essentially 135 times 23 divided by 10 gives me 311 milligrams per deciliter. Is everyone okay with those conversions? We're kind of going backwards here. We started with milliequivalents, went to millimoles, and went to milligrams. We'll keep doing this on and on. That's what we're doing the whole lecture today, is getting that skill down. Okay, one way or the other. And again, I won't belabor looking at the lower value. You can do that math on your own when you practice. Okay? Now let's kind of go the opposite direction, because now we want to do for chloride, and we want chloride in milliequivalents per liter, but we're starting with milligrams per deciliter. So it's really the same question for chloride, going the opposite direction. So let's start with what we are here. So on the low end here, the 341 comes here. And remember, the units we're starting with are milligrams per deciliter. So 341 milligrams per deciliter. We want to get milligrams to milliequivalents, but what do we have to go to first? We go from milligrams to what? Millimoles, and then from millimoles to milliequivalents. So there are going to be two steps in this conversion. So the first step is the relationship is we use the formula weight for chloride in milligrams equal to 1 millimole. Okay, so I was given, again, I will always provide you the molecular weights. So again, the molecular weights are all given here for this question. So for every 1 millimole, there's 35.5 milligrams of chloride. And remember, we're putting milligrams in the denominator, so it cancels. And now I have the number of molecules of chloride. Okay, 341 divided by 35.5. That number is the number of millimoles of chloride. But how much electricity will we get from that? Well, we have to look at the valence. What is the valence on chloride? It's a -1. So there's one charge. I don't care whether it's positive or negative. It's one charge. So there's one milliequivalent, one amount of electricity for every 1 molecule of chloride. Because the valence is 1, it's 1 to 1. So if I multiply by that, I can cancel millimoles and end up with milliequivalents. All right? And then lastly, remember I want to go from deciliters to liters, so I need to multiply by 10 to convert my volume units to liters. So if I do that math, 341 divided by 35.5 times 10 gives me 96 milliequivalents per liter. How'd you do on that? Can you go from milligrams to millimoles and then to milliequivalents? Is it the same thing going backwards? Just making sure you set up your ratios correctly. All right, let's do the easiest one of the bunch, magnesium here, because we want to go to millimoles per deciliter, and we're in milligrams per liter. So that's where we got to start with, and that's where we need to end up with. That's a shorter walk. To go from weight to millimoles is only a one step. So again, let's start with the lower version here. My units are milligrams per liter. All right, now of magnesium. Okay, now magnesium has a 2 valence. And the valence matter when we go to millimoles? No, the valence matters when we go to what? Milliequivalents. How do we get from milligrams to millimoles? It's formula weight. So again, I would take my formula weight here, bring it down and say for every 1 millimole of magnesium, there are 24.3 milligrams. So if I divide by that, I'm already there in millimoles. I just need to fix my volume here. Since I want to go from liters to deciliters, I need to divide by 10 so that liters cancel, and I end up with millimoles per deciliter. So 18.2 divided by 24.3 divided by 10 gives me 0.075. Okay? Now, let's see. I'm going to give you a minute to do this. Oh, I don't have much time. But let me see if you can try to do this. I'll give you a little bit of time because this is the hardest one in the sense of not any different than before. What I want you to do is convert calcium. So what you're going to start with, and just take the 8.5, start with the 8.5 milligrams per deciliter, which is a weight, milligrams per deciliter, and see if you can get it into milliequivalents per liter. Biggest trick there is starting with 8.5 milligrams per deciliter, convert milligrams to millimoles using the molecular weight, then convert millimoles to milliequivalents using the valence on calcium. So again, I started with 8.5 milligrams per deciliter. I want to go from milligrams to millimoles as my first step. What's my relationship? That every 1 millimole is equivalent to the formula weight in milligrams. So for every 1 millimole, there are 40 milligrams. So I need to divide by 40 to cancel milligrams, and now I'm in millimoles. Okay? Well, how do you go from the number of molecules to the amount of electricity generated by those molecules? Is you look at the valence. Since the valence on calcium is 2, then there are 2. This is important. Make sure you can understand that. There are 2 milliequivalents for every 1 millimole. 1 molecule of calcium produces 2 electrical charges because the valence is 2. So you get 2 charges from every 1 molecule of calcium. So that's why we need to multiply by 2 so that millimoles cancel and we'll be in milliequivalents. And lastly, again, we multiply by 10 to convert deciliters to liters, and you get 4.25. Okay? Well, let's do this same skill over and over again with different questions. Essentially, there'll be different questions, but it's the same math. You'll say the same math of converting from milligrams to millimoles to milliequivalents. That's what we're going to do, or work backwards. In this case, we're going to work forwards because it wants to know how many milliequivalents of aluminum are contained in 2 tablespoons full dose of this antacid. And this antacid has 400 milligrams of aluminum hydroxide per teaspoonful. Okay, so the first thing we'll do with is aluminum hydroxide. I give you the formulas there, I give you the molecular weights, I give you the volume conversions down below here. So, where do we start with? Let's start with how much are we giving? We are giving 2 tablespoonfuls. So that's what we're going to start with. That's what the amount of milliequivalents we want to find in that dose. So let's start with 2 tablespoons, okay? And then we're just going to go through conversion after conversion after conversion. The first conversion is to convert tablespoons into milliliters. All right, so would you agree there are 15 milliliters per tablespoon? So multiply that by 2, tablespoons cancel, and I've got now 30 milliliters. 30 milliliters is the volume of my dose. Next, I'm going to take my concentration of aluminum hydroxide at 400 milligrams of aluminum hydroxide per 5 mLs. This is where the teaspoonful comes in down here, okay? 500 milligrams per 5 mLs. So when I multiply my 30 mils times that, divide by 5 and multiply by 400, I will be in milligrams of aluminum hydroxide. Is everyone okay so far? That's kind of chapter 7, 8 kind of dosing thing where you have to mess with the volume a little bit and calculate based off of the concentration how much drug we would need. So we're now in milligrams of aluminum hydroxide. Well, we want milliequivalents. So we go from milligrams to what? Millimoles. So first we got to go to millimoles. How many molecules are there in that many milligrams of aluminum hydroxide? Well, let's take the formula weight in milligrams is equal to 1 millimole. So when I divide by 78, I'm canceling milligrams, and I'm now in the number of molecules of aluminum hydroxide. Okay, are we good so far? Because this is where then it's going to get a little more difficult than the ones we practiced on, okay? So I have molecules of aluminum hydroxide, but I want milliequivalents of aluminum, just the aluminum. I don't care about the hydroxide. I want to know how much aluminum. So you have to look at the formula for the molecule. How many aluminums are there for every 1 aluminum hydroxide? 1. How many hydroxides are there in 1 aluminum hydroxide? 3. There are 3 hydroxides and 1 aluminum. That's important when I'm saying when you look at the formula, you got to understand that part of it. Since we're talking about aluminum, this is now the proportion. There is 1 millimole, 1 molecule of aluminum for every 1 millimole molecules of aluminum hydroxide. It's 1 to 1. That lets me convert from millimoles of aluminum hydroxide to just millimoles of aluminum. So do you see the purpose of this step right here? Is everyone okay with that? That converts from the molecules of the parent molecule, aluminum hydroxide, to the molecules of just aluminum. Okay, in this case, it's 1 to 1. It won't always be that way. You'll see that. Okay. Now, I still want to go from millimoles to milliequivalents. And where did we say to look? The valence. So what is the valence on aluminum? 3. It's a positive 3. So there are 3 milliequivalents for every 1 millimole of aluminum. You get 3 electrical charges for every molecule. So when you multiply by 3, millimoles cancel. And you ultimately get 92 milliequivalents of aluminum. Okay? Everyone okay with that? Would you see we still have the 3 steps? Here's milligrams to millimoles to milliequivalents. Okay, after we did this middle step to convert from the parent molecule to just the aluminum. Okay, you look thrilled. All right, let's do the same thing with magnesium. What will be different? Everything will be the same. You know, in this sense, we have the same concentration where it's 400 milligrams per teaspoonful, so even that's the same. But clearly the molecular weight of magnesium is different. All right, so that'll be a difference. And also, what is the charge on magnesium? Can you tell that by the MgOH2? It's 2. It's a positive 2. Instead of a positive 3, it's a positive 2, and we have a different molecular weight. But other than that, it is set up exactly the same. Okay? So I start with my 2 tablespoons over here, and then I convert tablespoons to milliliters. Then I take my concentration of magnesium, 400 milligrams per 5 mLs. So do you see where we've canceled our volumes from milliliters, and using the concentration, I now have milligrams of magnesium hydroxide. Okay, so that step sets up just the volume. Okay, and so from the volume then we can convert using concentration. We've got it into milligrams. Now I want to go from the weight of magnesium hydroxide to the number of molecules of magnesium hydroxide. So let's take its molecular weight and divide by that so that milligrams cancel, and I'm in millimoles. Right? How many magnesiums are in a magnesium hydroxide? 1. So you'll see here, make sure you understand the step here because this will be important later. 1 magnesium for every 1 magnesium hydroxide. And then lastly, since the valence is 2, you get 2 milliequivalents of magnesium for that. So in the end, we get 82 milliequivalents of magnesium for the final volume, final amount. Okay. Now, since next up I wanted to show the answer, I only wanted to show you this because it's a stupid question. Let me just tell you this. Okay, we got 82 from the magnesium and we got 92 from the aluminum. So when you think about how many milliequivalents of hydroxide there will be the same numbers. You'll get the same total of hydroxide as you did from aluminum, and you'll get the same total from magnesium because those molecules are not charged to begin with. Would you agree? Magnesium hydroxide has no charge because the magnesium is bound up with the hydroxide. The problem is when you take them into your body, they dissociate, so they separate. So it's not a surprise that they have the same total amounts, but I wanted to make sure, let me quickly make sure you understand where there are some differences. So let's just start again. We're starting with 2 tablespoons here and we're trying to find the hydroxide. From the aluminum hydroxide, we do the same math to convert the volume. We do the same concentration to convert volume to weight. And again, we use the same weight to convert to molecules of aluminum hydroxide. So everything is exactly the same at this point. We have the same total molecules of aluminum hydroxide. But now we want to go to hydroxide. So how many hydroxides are there in 1 aluminum hydroxide? 3. So that's where that 3 is. Do you see where there are 3 aluminum hydroxide molecules for every 1 molecule of aluminum hydroxide? But the valence is only 1. So again, now the charge is 1 milliequivalent for every 1 millimole, but since there are 3 of them, that's how we end up with the same answer. Okay? You see that this is different than it was for the aluminum. The same process, but the numbers are different. Because we have 3 molecules, even though each one only has a charge of 1, whereas when we did aluminum, there was 1 aluminum, but there were 3 charges from it. And that's how we ended up with the same numbers there. Okay? All right, I can't tell if it's bored or confused. All right, let's move on. That was getting a little bit old there, so this is a little more straightforward. It's kind of a silly question, but let's just do it this. A patient takes 1 potassium chloride 10 milliequivalent extended release tablet by mouth twice a day to prevent hypokalemia. What does the fancy word for hypokalemia mean? Low potassium, right? So they want to avoid low potassium by taking a potassium chloride. First question is, how many milligrams of potassium does the patient consume each day? All right, let's just do this. So I kind of skipped this step, but the whole point on this is there's 1 tablet, how often? Twice a day. So how many tablets per day? 2 tablets per day. So that's where I'm starting off with. That's where the 2 tablets come from per day. It was a little bit of a trick. Each tablet contains 10 milliequivalents. So 2 times 10 is 20 milliequivalents of potassium. That's how much they're getting from their tablets. All right. How many millimoles are in 10, or I should say 20 milliequivalents? Well, there is 1, because the charge is 1, there's 1 milliequivalent for every 1 millimole. So again, that'll convert from milliequivalents to millimoles. I take the molecular weight, and I say the molecular weight in milligrams. 39 milligrams is equal to 1 millimole. So if I multiply by 39, millimoles cancel, and 2 times 10, which is 20, times 39 gives me 780 milligrams of potassium per day. Are you able to do that? Okay, I know I was rushing some of you, but that's kind of a straightforward milliequivalents to millimoles to milligrams. That's the idea. Now, this is pretty straightforward. A person wants a normal recommended daily amount is 4,700 milligrams per day. So how much additional potassium do they need from their diet? They're going to get that 780 milligrams from the pills. How much do they need from their diet? That's a pretty straightforward subtraction. So 4,700 milligrams total minus 780 from the tablets means they still need to get 3,920 milligrams from potassium. All right. So let me ask you, where's a good source of potassium? Bananas. Bananas is really good. That might be a lot of bananas. What's in the liquid form of it? Orange juice. Orange juice is a really good source. So this person wants to get the rest of that amount, the 39, what was it, 20? 39.20 from their orange juice. And their orange juice provides 8.5 milliequivalents of potassium per 6 fluid ounces, knowing that a fluid ounce is 30 mils. How many milliliters do they need? So I'll give you a minute to do that. Remember, your starting number is 39.20. That's what she wants. She wants to get half of that. So let me back up. She wants to get half. I didn't say that very good when I talked about it. So of the 39.20, she wants to get half of that from just some orange juice. So provide half of that total, 39.20, and tell me how many milliliters of orange juice does she want to drink each day. So I started with 39.20, which was my answer, divided by 2 so that I get half of that amount. I'm in milligrams, so I'm going to take their molecular weight of 39, divide by that so that I can convert milligrams to millimoles. Then I know the charge on potassium is 1, so there's 1 milliequivalent for every 1 millimole. Then I'm in milliequivalents, right? To get milliequivalents to volume, I'm going to use the concentration of potassium in my orange juice, which I said was 8.5 milliequivalents per 6 fluid ounces. So if I divide by the 8.5 and multiply by the 6, then that gives me units of fluid ounces. And then I'll take my 30 milliliters per fluid ounce to multiply by that, multiply by 30, and I get basically a liter, 1,064 milliliters of orange juice. Was that a good plan? That's a lot of orange juice, so now I think maybe some other sources would be a good idea. So anyways, everyone okay with that? All right, now I'm just going to work through this one, but this is a really good example of a good test question. And I know there is an endless practice problem that does this where you have to go between dosage forms. In this case, we have a patient taking a certain amount of lithium oral solution that contains 608 milligrams of lithium citrate per teaspoonful. So I eventually want to convert them to lithium carbonate capsules. So that'll be part 2. First step to do that is to figure out how much lithium, how many milliequivalents of lithium are they consuming with their current dose of lithium citrate. Since they're taking 2 teaspoons full, let's start with that. So I'm going to start with 2 teaspoons full. That's a volume. And I'm going to take the concentration given at 608 milligrams per teaspoonful. So if I multiply that, teaspoons cancel and I'm in milligrams of lithium citrate. I gave you the formula for lithium citrate and its molecular weight. So now I can go and convert milligrams to millimoles by dividing by the molecular weight. Have I said that before? I know you're tired of it. We divide by molecular weight in milligrams to convert to millimoles. Okay. Now this is the trick. Let's look at the formula. How many lithium molecules are in 1 molecule of lithium citrate? 3. Do you see where it says Li3? I want to make sure you see where that number is coming from. Because there are 3 lithiums in there, that means there are 3 millimoles of lithium for every 1 of the parent molecule. You get 3 lithiums from every 1 lithium citrate. Okay? That converts from millimoles of lithium citrate to millimoles of just lithium. Then I can convert to milliequivalents by looking at the valence. Since the valence is 1, it's 1 to 1. 1 milliequivalent for every 1 molecule of lithium. So if you do that math all the way across, you get 16 milliequivalents. That's how much? 16 milliequivalents of lithium is coming from their dose of lithium citrate. So now, how do I get 16 milliequivalents of lithium using 300 milligram lithium carbonate capsules? So it starts with what we want. We want 16 milliequivalents of lithium. That's what we just solved for. Now we've got to go backwards, all right? So to go from milliequivalents to millimoles, we use the valence. The valence is 1, so there's 1 molecule of lithium for every 1 milliequivalent, 1 to 1. But now we have to look at the formula here. How many lithiums are in a 1 lithium carbonate? 2. So there are 2 millimoles of lithium for every 1 millimole of lithium carbonate. And you see now we put millimoles of lithium in the denominator because that's what we're starting with. We're canceling out the number of lithium molecules and figuring out how many molecules of lithium carbonate we would need. All right. Now we're in lithium carbonate molecules. We can convert that to the weight of lithium carbonate by multiplying by the molecular weight. That converts molecules to milligrams. And that's, I think, really the most straightforward one. Then the last step is to convert to the number of capsules. Once you have the weight that you need, you're using the fact there's 300 milligrams of that per capsule. So that in one cap there's 300 milligrams. If I divide by 300, that would proportion out the weight into capsules, and I get 1.97 capsules. Clearly, we'd round that up to a total of 2 capsules. So you see where 2 capsules provides the equivalent of 2 teaspoonsful of the lithium citrate. Okay on that one? That is definitely a good example of a testy type kind of question. All right, you seem stressed, so let's get you some antacid. This will help your stomachs here a little bit if you're having any issues. So in this case, we have the original Alka-Seltzer, the Plop Plop Fizz Fizz tablets at 1,960 milligrams of sodium bicarbonate, okay, in each tablet, and that was used. We also have the original Tums tablets with 500 milligrams of calcium carbonate. So again, Tums is here, Alka-Seltzer is here. The first thing we want to know, the active thing in those is not the sodium, it's the bicarbonate. Bicarbonate is what will bind with the acid and kind of neutralize it. So first question is, how much bicarbonate, how many milliequivalents of bicarbonate are in the 2-tablet dose of the Plop Plop Fizz Fizz Alka-Seltzer? So let's start with the 2 tablets. 2 tablets. Each tablet has 1,916 milligrams of sodium bicarbonate. So if I just multiply that, I will get my total weight in milligrams of sodium bicarbonate. But remember, I want milliequivalents of just bicarbonate. So let's convert from the weight of the sodium bicarbonate to the number of molecules by dividing by its molecular weight. Make sure you know where all these numbers are coming from. Now I'm in molecules of sodium bicarbonate. Let's split that molecule in half. There is 1 sodium in every 1 sodium bicarbonate, meaning there's 1 bicarbonate. So here we have the 1 bicarbonate out of the 1 sodium bicarbonate. So now I'm in millimoles of just bicarbonate. And again, looking at the charge here, it's a -1. So there's a 1 charge for every 1 molecule. So again, that would in the end give me a total of 46 milliequivalents of bicarbonate. Now, that's what we want to get from our Tums. So how many Tums tablets would be the same as those Alka-Seltzer tablets? So that's why we're starting again with 46 milliequivalents. But now we're not in bicarbonate, we're just of carbonate, because we're going to be using calcium carbonate. So we're starting with milliequivalents of carbonate, because that's what we want to solve for in our Tums tablets. But it would be equivalent to the same amount of bicarbonate. All right? So starting with 46 milliequivalents of carbonate. Let's convert that to the number of molecules, or millimoles, by looking at the valence. Now, though, the valence on carbonate is 2. So there are 2 milliequivalents of carbonate for every 1 millimole of the carbonate. All right? So if we take our 46 milliequivalents and divide by 2, you would get essentially 23 millimoles of carbonate. All right? How do I go from carbonate to calcium carbonate? Well, we'll look at the formula. There's 1 calcium and 1 carbonate for every calcium carbonate, so it's 1 to 1. So if I divide basically like that, then it cancels that out, and I'm in molecules of calcium carbonate. What was its molecular weight to go from millimoles to milligrams? It's 100, so it's 100 milligrams per millimole. That would give me my weight of calcium carbonate. And lastly, it's a 500 milligram tablet. So if I divide by 500 milligrams per tablet, I get a number 4.6, so clearly we have to round that up to 5. So we would round that up to 5 whole tablets to get as close as we could to the amount of 2 Alka-Seltzer tablets. Okay? All right, so now the question is, how much calcium are you going to get from that? If we start with 5 tablets, all right, that's what we just decided we had to do. They're 500 milligrams per tablet. All right, so now we've got essentially the 500 milligrams. Well, let's convert that to the number of molecules by dividing by the molecular weight, okay, which is 100. So now I'm in the millimoles of calcium carbonate. I want to know calcium. The whole point of this parent molecule is to figure out how much calcium. It's still 1 to 1, so 1 calcium for every 1 calcium carbonate. That would turn me into calcium. But to figure out milliequivalents, I have to use the valence on calcium of 2. So you're going to get 2 milliequivalents for every molecule of calcium that you have. So when you do that math all the way across, you get 50 milliequivalents of calcium. Every time you chew, 5 tablets. All right. I warned you that the last question was going to be a crappy one every class now for a while, because we're talking about laxatives. So have you guys ever, you work in pharmacies, you ever dispense, oh, I don't got no time, but have you ever dispensed the big jugs of powder that people use when they have a colonoscopy where they have to power wash the GI tract? Well, why do they do that? Well, because As we'll do next class, we'll talk about the osmotic forces. We'll talk about osmotic. For now, we're just talking about the amount of the different electrolytes in there. So I'll just power through this one as well. I'll work on one in detail. So in this case, if we wanted to figure out how much potassium chloride was in there, you would take the potassium chloride in grams, convert grams to milligrams. Because remember we said the formula weight was the number of millimoles per milligram. Now we're in there. There's 1 potassium for every 1 potassium chloride. There's a charge of 1, so there's 1 to 1 again, and that's where we got 40 on there, okay? I won't belabor this point. This question works the same for all of them. Just remember, when we want the total amount of sodium, you have to add all of the sodium ingredients together. So it's a matter of adding all of those together. And then lastly, the question wanted it in milliequivalents per liter. Keep in mind that these weights were per 4 liters. So the last step there is to divide that total that you sum all that up by 4 to make sure that you express it in per liter when you look at the key on it.